Transcription stopped, recording started. Good. Okay, welcome everyone to the September Northwest C++ users group meeting. Just a quick note, we will not have a meeting next month as we'll be honoring CPPCon. With that, Chris, any announcements for CPPCon?
We beat last year's attendance so far, but we got lots of spots left, so sign up to come.
Okay.
You can see Nevin give this talk again.
Not this talk again. I got other talks I'm working on.
Okay, and with that, I'll just hand it over to Nevin.
Hello, I am Nevin Lieber. I work. You trying to figure out how to scroll on this thing? There we go. Who am I? So I work at Argonne National Laboratory in Lamont, Illinois. I'm a remote employee, so I work from home. I'm a computer scientist there in the Leadership Computing Facility division. And I work on three things. I work on C++, on Kokkos and SYCL. I work on the Aurora supercomputer. And on the C++ committee, on the international one, I'm the vice chair of the Library Evolution Workgroup Incubator. I'm also the admin chair. And on the US delegation, I'm the vice chair of that. And for Argonne, I'm also the Chrono SYCL committee member. So what is SYCL and what is Kokkos? I mean, because those are things people here may not have heard of. So SYCL is they're both performance portability. So it basically, we want, we do like lots of high performance computing, like lots of simulations, and we want to be able to, for us, every time we get a new supercomputer, it's got a new architecture, and we need to be able to port things to it. So SYCL is a performance portability, but it's the vendor provided tool chain. Like Intel is right now has put it into LLVM. It allows language extensions, and it's got both implicit and explicit data movement. By implicit, like you can say, I want to do this thing and have these calculations done on a GPU, and you just kind of say like, do this in parallel, and the data will automatically move. It's got a fixed layout in 3 dimensions. We are right now working to eliminate those limitations. Because SYCL came from OpenCL, it's really, it started out graphics based, so 3 dimensions was fine for them, but for the stuff we do, we need, 8 dimensions is good for us. Now, Kokkos is also performance portability, but we leverage the vendor toolchain. It was developed initially by Sandia Labs, and we use it a lot inside the Department of Energy National Laboratories, and others can use it as well. It's pure open source. It's a pure C++ library. But for data movement, if you need to have data, you have to say, I want to put this data on the GPU, perform it, and then I want to bring this data back to the CPU maybe. And we have a lot of different backends. We can use on CUDA, on HIP, on SYCL, OpenMP.
Oh, on the side, of course.
Because I've taken Sunny out front.
No, that's closed,
That's
yeah.
fine. Okay. While I'm out there, I'll lock the front.
Okay, we're good.
So that's just a brief introduction between SYCL and Kokkos. And now what the talk is actually about, what is MDSPAN? So MDSPAN is a non-owning multidimensional array view that was added to C++ 23. It's what we call a vocabulary type, and by that I mean something that we can use in interfaces and use across domains. Right? It's not just for high-performance computing, it's for really anybody who's doing things with multiple dimensions. And roughly this is what it is. It's got 4 template parameters and an indexing operator. So the first template, first template parameter is the element type. I mean, that's just like, that's what it's wrapping around. Remember, it's not owning, so it's wrapping some other kind of, maybe an array or data somewhere else. Next comes extents. And extents describes the dimensions of the multidimensional array. And we have kind of 2 classes. We have extents and then de-extents. Now, extents has a type that is actually used for indexing, like it can be int, can be size t, whatever you need. And then each of the dimensions. Like you can say, like if you say like 2, 3, 5, then you've got, a 3-dimensional MDSPAN. The first dimension is 2, the second is 3, the third is 5. If you say standard dynamic extent instead, of actually providing a number there, then it is done at runtime instead of compile time. The reason we want to compile time sometimes, if we know the number, is because we can get better optimizations that way. And the E's are a size T because dynamic extent is size T. Dynamic extent came with SPAN and C++20. And D-extents, because most people want dynamic extents, it's much easier to use. It's really just with some template metaprogramming. D-extents in comma 3 is just an alias, a template alias for extents in dynamic extent, dynamic extent, dynamic extent. We really did try in C++20 to get the name shortened, but the committee wouldn't go for it. So we wanted standard din instead of standard dynamic extent. Anyway, next comes layout policy. And what that does, it describes, is it row major order, column major order? Is it strided? Like layout right is row major. That's the normal C++ and C ordering. And the rightmost extent is the contiguous one. I mean, layout left is the Fortran ordering, and the leftmost extent is contiguous. And you can also have user-defined ones. At CPCon last year, Teamer, as part of his keynote, I think came up with a different layout, if I remember right. And he did it like in under an hour and had it working. So, and here's kind of what the mapping class looks like. I mean, there's really not that much to it. It's just like, is this, is it strided? Is it, is it all the unique, etc. And finally, there's the fourth template parameter is the accessor policy. And that's just how do you actually get to the data? We can customize the pointer and reference types here. We can add things like restrict, which isn't, it's standard in C, not standard in C++, but it does help a lot in getting optimizations. You can add remote memory, you can do compressed memory. You can even do like atomic access. Like if you use atomic ref to get to elements, you can get atomic access for that. And I'll talk about that in a bit later. And here's what default accessor looks like. And like the two things, like there's access and offset. Like access is just like, P square bracket I, and offset is P plus I. And that's just a way to customize that. And you can, there's some other constructors, but you construct it basically with a pointer and a list of dimensions, list of extents. And to dereference it, right? It's just the square bracket operator, and you just put all, M like 2, 3, 5. In C++23, we added the ability to have multiple dimensions inside square brackets. And that's, 8 years it took us to get here. How did we do it? Yeah. And we're still making minor changes to it and other additions, but way back in 2014, only like my, I don't know, 4th year on the committee, Lukács and Herb came up with array view. And only had static extents, and like you pass it a bounds rectangle and like a pointer to data, and then you could dereference it with its own type, with its own index type. And there's also a strided array view as part of that. And, we talked about it in SYCL in 2014, and, we kind of wanted a variadic square bracket operator, but nobody wanted to wait for language support. And we'd also like to be able to have dynamic extents and static extents, in the same data structure. So what we do on the committee is that we take lots of polls to gauge what the library design groups and language design groups, what they feel, and then eventually we're looking for consensus among all the committee members. So we took a lot of polls on array view, and the way polls are, you'll see when you see 5 numbers, it means that the first one's strongly in favor, the second weakly in favor, neutral, weakly against, strongly against. So if you look at are people comfortable with a square bracket, and because the comma operator can be overloaded, you have to put that, you would have to do that kind of thing to it. And would people be comfortable with that syntax? Yeah, kind of. It's like, 10 to 12 people in favor, right? If you count neutrals, to 5, it's very weak consensus. How about, the only variadic one we had at the time, like was, operator paren. How about that syntax? Not really. People didn't like it. How about both, right? Nobody wants both. Should we delay this paper until there's a fixed array view, which is like all fixed dimensions? No, I don't want to delay it. Should there be iterators? And we're not really sure the right way to do iterator support for multiple dimensions. So no. How about layout? Should we be able to affect layout? Yeah, that'd be kind of nice. Should we wait? Should we hold up the array ATS for layout? No, absolutely not. And then put the array view in the array's technical specification. That looks pretty darn, that's pretty strong support to doing that. And had that happen, this would be a very short talk, but it didn't. Yes, the array's technical specifications. So technical specifications are they're official documents, official, and they're usually, we use them for things when we don't know all the issues, right? So we want to put something out there that people can use officially and try to work through some of the issues we're not sure we want to put into the international standard. So this was born in 2013 in Chicago meeting. And this all came about because there was a proposal to do runtime size arrays with automatic storage duration, like arrays on the stack. Right? But there were no bounds checking, you can overrun the stack easily, and there's no safe way to exit, no iterators. And so we started looking at what are the different possible container types we could map onto this, right? So right here are a bunch of them. You see all the stuff for in-place vector, like static vector, then fixed capacity. In-place vector right now is going through the committee. It is being voted upon in LEWG in electronic polling. It passed in Varna. So hopefully that will get in. I'm working on that one. I'm also working, I was working on small vector. I have to come back. Now, the reason I called it clump was I knew it would be a name so bad that nobody on the committee would like it. And I was right. So I got small vector for it. I doubt the name will live because the committee really likes longer names, but we'll see. So, looking at these things, right, it turns out DynArray is the one that kind of maps onto this thing, right? It models exactly n elements, which is the same thing that ArrayView does, right? Or sorry, thing stack array does, right? And its capacity is at runtime. So that had been an old proposal and it got resurrected. And if you notice, we'll go back a sec, right? It's not, the allocator is not a template parameter here because it's actually passed in because it doesn't have to ever reallocate. Once allocated, it's done. But there were some questions about this, like how does stack memory work if this type's embedded in another type? And what if that aggregate type is on the heap, right? Is there part of the memory in stack, part of it on the heap? And compiler writers, like I said, we have no idea how to actually make all this happen. So there was an impasse. And to solve the impasse, well, we have open questions. We don't know how to solve them. Let's do a technical specification to sort it out. And because we had one in Issaquah, it's like, hey, let's add all the array-like things we want to put in the standard to it because documents like to expand. So array view. There was an array ref proposal, which is like span, string ref, which eventually became string view. One of the things was instead of having standard array be single dimension, make it multiple dimensions. And then make array to create those things, and then also to extend shared pointer and make shared to support arrays. So there we go. Well, a couple years later, nothing actually happened. We put all that stuff in, nothing actually happened with it, and then it's like, should we kill it? Yeah, because it really wasn't getting anywhere. We weren't actually making progress, especially on the one major thing we cared about at that point, which was stack-based arrays. So C++ still does not have stack-based arrays. So back to 2014 in ArrayView. So in Rapperswil, right, this is revision 2. Wording had some minor changes, and it's like, hey, let's send us a library fundamentals technical specification. Sure, let's do that. We're a very optimistic group, if you haven't noticed yet. We think we can ship a lot earlier than we actually do. So version 3 had some minor fixes. Vision 4, hey, let's make a formal motion to put it in the, put it in the standard. And then after the Urbana meeting, another paper got discussed. And should we have like, layout, static extensive template parameters, a fixed array view, and then the operator paren for lookup. And so should we take out the one-dimensional version from the multidimensional one? Not really. If square bracket comes along, we should use it. But again, there's no real proposal at that point. Sure. And should we allow square brackets for just the one-dimensional case? Because it makes it, right? It's when people think of arrays, they think of using square brackets. Sure, why not? And then Carter Edwards from Sandia, was working on Kokkos at the time, didn't like this at all. Like array layout has significant impact on performance, including SIMD. There should be including tiling and padding. Strated has to be an option. You need to be able to mix, compile, and runtime dimensions. And some minor stuff like the index and bounds of way back of the original proposal, that's really just standard array. And kind of like, if you have array view of T rank, it's not the same as array of T common length. Like rank and length are different things. People might get mixed up. And it doesn't really talk about how we interact with memory management. And that kind of matters in HPC because, again, we're putting things onto GPUs. So, how we move memory around matters. So the recommendation of this was to delay array view until the array TS. 2015. Okay, so we're down 1 year now, right? If you're counting. Vision 5 is we had a library-only meeting in Cologne. Half of that was to try to get networking out the door. We don't have a networking library, sorry. And so half that group worked on networking, and I was in the other half. We worked on like everything else that we had to talk about for the library. And again, one of the comments here, like looking in good shape to move in Lenexa. We were really optimistic. So Lenexa, there were changes from Cologne that were incorporated. And then like the formal motions page came up, right? So it was LWG motion 6, apply this to the library fundamentals. There's a big discussion. But some of the ISAQA feedback of, people saying, well, this isn't quite doing everything we needed to do, and there's performance things. And those issues were also raised in Rapperswil. And again, those papers, pointed it out. And so LAWG supported the direction of the papers saying we need, all the things we need, threaded and stuff. So that, we took a vote that this is the entire committee vote, right? Yes, no, abstain. That is not consensus. So that motion was withdrawn. So I'm going to switch gears a little bit because Kokkos view is really what Carter was working on. And that's where he got, his real world experience on that is what influenced his views. And what Kokkos view is, it's a multidimensional array of 0 or more dimensions. It has 4 types. I'll get to how that really works, but you can think of it as the first one and the other 3 are just optional. Data type is, of course, same as, element type, what you think it is. And except it had like this kind of there's this tierce notation that can be used. Right? And the only requirement is that it must be valid C++ syntax. And kind of that tierce notation means if you're using like an asterisk, that means wildcard, like, we're used to from regular expressions. And square brackets with numbers, that means a compile time dimension. So if you have a view double star star, that's a 2D view of double with 2 runtime dimensions. And a view, a constant star 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 5.3 is a 5-dimensional view event with 3 runtime and 2 compile time dimensions. And because it's const, the data is read only. So lots of cleverness, and it is very terse. And useful for people, I use it. Definitely very useful, but it's a harder sell. And you can index it with a, variadic operator if you need to, or in one-dimensional ones can be done with square brackets. One of the not so, in my opinion, things I don't quite like so much about it is it's sometimes owning, like Kokkos parlance, managed or unmanaged. Like owning means that it has the data and it's responsible for destroying the data afterwards. And it's also sometimes reference counting because we have in order to put things on the GPUs, we have to basically mem copy them. So we can't up the reference count, so we don't do the reference counting on devices. And that in practice that works fine, but it's you know, it's still, you know, it does bother, you know, like it should all just be reference counted because they are references, but it does work fine. Next comes layout type, which is, you know, again, right, layout left, layout right, you know, row major, column major. Memory space is like saying, where does the memory? Is it in the CPU? Is it GPU? And then memory traits are for like, you know, it's where manage and manage comes, you know, it's where, you know, atomic or random access hints you can give it. You can add C restrict there. Now, under the covers, how this actually works is that there's a variadic properties template parameter that we walk through the property list and try to find the right properties. Meanwhile, back in Lenexa, so Carter and Christian runs the Kokkos project, Christian Trott. They come back and they go, hey, you know, we're going to propose this shared array for the owning one and weak array for the non-owning one. And again, you know, with a size type, because being able to customize the size type is important. And also this weird, this language change, like we should be able to just use square brackets. Like if we could use square brackets everywhere, then we didn't, right? So I kind of cued a little before when I said like, it has to be valid syntax, right? So for valid syntax, like star, square bracket number is fine, but you can't put square brackets first because that's just not valid C++ syntax. So let's have a language change that would allow that, right? Empty square brackets would be even one you could use, but just if you could just put them anywhere, then it would work. And it's much harder, you know, this is a much harder sell when you're trying to make language changes than just adding a library. So should we allow square bracket for rank 1? Yeah, I mean, there were a few people who didn't like it, but yeah. And around this time, like Neil McIntosh, like also does, you know, his version of array view. And but I just give you like, you know, this is where standard byte came from this proposal. And the only real differences between class byte of UNAT and the one that's in the standard, the one in the standard is guaranteed to allow type punning, and the one above it is not. If you do num class byte, you cannot do type punning with it. And another thing, because safety is becoming very important, if you construct an array view with invalid values, if it can figure out it was an invalid value, like you can't figure out if it's an invalid pointer, but you can figure out if like dimensions are wrong or something, then it should terminate instead of undefined behavior. And you can do a whole other discussion on that. And come to CPPCon. I mean, you should come, but yeah, we're going to be talking. I know, not likely. I know we're going to be talking about that. So here's his proposal. Like there's this index class for indexing it, and then a bounds iterator, so you can iterate it, and then you can use threaded bounds. And then there's like this useful thing to talk about dimensions and whether you want it static or dynamic. And then this view traits, like so it'll be size t to start with, unless you pass in view traits instead of the value type. And then if you pass in array view traits, you could change the type the size type inside of it. And then like there's another iterator, and yeah, it's a lot of stuff. So I remember this proposal. I remember sitting on this discussion, and I thought it was way too complicated. But I didn't need it in the work I was doing at the time. So the people who need it will figure this out. Maybe they need this complexity. If only I knew. 3 years later, to the day, I would be working on this stuff. And so as part of this, SPAN got factored out for one-dimensional stuff. And because of the whole complexity, I stopped paying total attention to it. Until SPAN was about to go into the standard. So if you don't like that, if you don't like us using size t, I'm sorry. It in a lot of ways is my fault. What happened was a friend of mine who was between jobs, so he wasn't technically a committee member, said, "Hey, Nevin, you need to protest this." And I go, "Why?" And it's like, well, because it breaks interoperability with the rest of the standard library. It's like, oh, you're right, and I do. So I led the charge. I was up against like Bjarne and Herb Sutter. And this is all before I was in high performance computing. So I thought the performance differences were minor. which is what every committee member says when they want a feature. The cost is negligible. If you don't want a feature, every committee member goes, I can't even afford one cycle. Like how dare you compare a null pointer? Like this happens all the time. But there were no actual performance numbers. Like no one proved the performance differences were more than minor. So, and from my point of view at that time, it was more important was interoperability with the rest of the standard library. P0009, right? So our paper numbering system, we have a bunch of end papers, which ISO requires us to always publish. And we kind of moved to P papers, which are papers we can publish internally, but we don't have to like move over to ISO every time and give them copyright and stuff on it. And so this is one of the first papers on our new paper system, right? Well, the ninth paper, right, on our new paper system. And so this was the multidimensional array view. And I want to point out that it's not just it's not just from the Kokkos folks trying to propose it, right? It was trying to get buy-in among a whole like finance and schools and all sorts of places, right? AMD. And this was all the things Carter didn't like about the array view. This was like, how to fix it, right? And the layout's more general. You can have different ordering. You can have padding. You can have interoperability with libraries that have compile time extents, and zero overhead for extents and strides, all this good stuff. And kind of looks like Kokkos view, doesn't it? Except it's a lowercase v instead of an uppercase v. So there's an issue with properties, though. So if you either pass a property or, that kind of like the empty square bracket thing, right? But there's another issue with that besides the second one didn't exist, still doesn't exist in C++, right? Is that those two, view of int and property implicit dimensions 3 and view in square bracket, square bracket, square bracket are different types, right? They're equivalent types, but they're different. So if I want to pass this thing to something, what do I do, right? And there's really only 3 options, right? You can have separate overloads, and that can get unwieldy, right? There's just 2 ways of saying it. What if there's more than 2 ways to say it? You can pay a small runtime conversion cost. I mean, it's usually small. Sometimes it's nothing. Or you stay in template land and do all your stuff with templates. None of those are really satisfactory. Well, we took some, we took some more polls, right? Do we want 0 length extents? Sure. Not everybody though, but yeah, it's still, do we want property lists? Yeah, we like property lists. That sounds good. And do we want bounds checking? Again, safety is, we hadn't really formalized like how safety is important and if this is what we want, right? Because, bounds checking impacts performance and, and has to have error handling. So in Kona in 2015, so bike shedding basically means we're trying to figure out the right name for something. My personal opinion is names are extremely important. The way the C++ community does naming is really bad. Like usually it's let's have a list of names, we'll put them on a dartboard and throw darts at it. It's close to that. And we spend 2-3 minutes thinking about it for something that's going to last forever. So that's not really good. And the other thing behind this is what do we do about errors, right? And there were some proposals about contracts going on at the time. I'll give a sidebar about that one too, because I think that's right. So C++ only has one knob that says "Here be dragons, don't go there," right? And that's undefined behavior. And everything else in C++, right? Everything else is defined behavior of some sort. And developers will write code dependent on defined behavior, right? If it's integers, for instance, unsigned integers can wrap, right? Developers occasionally write code where that matters. Most of the time it's a bug, but occasionally it's correct. So if you define all undefined behavior, you get people dependent and you don't know if they accidentally are dependent on it or deliberately. So what we're hoping is contracts, which are, I don't want to say glorified, they're more than just assertions, but they give, will give you preconditions, postconditions, assertions, a whole bunch of things. And hopefully in C++ 26, the contracts folks are working very hard to, make that happen. And I think personally think that's the correct solution for this kind of thing. And now back to our favorite, P0009, R1. So view is now called ArrayRef, and there's still the ongoing debate about should we have a signed or unsigned size type in there. R2, which is pre-ULU meeting, some layout mapping stuff, and the relaxed array declaration syntax is kind of like, the language changes move to a different paper. And at the time, Library Evolution asked for like motivation examples, and kind of like the description stuff moved to one paper versus just the technical, this is the wording kind of thing. We have since reversed that decision. We like having them both together so we could read, something reading through the prose, like, oh, this is why this works this way, is really important. And as part of our 3, there was this something called the undesirable extent mechanism B proposal, which was to pass in an extents templated data structure. Undesirable. So R4, we're in Albuquerque. It's now renamed to MDSPAN. It's aligned with SPAN. Extents, the undesirable mechanism, is now part of the proposal. Still kind of hoping for the shortcut. Should be able to index this with SPAN, because that would make sense, right? Right? SPAN describes a one-dimensional, right? It's a one-dimensional view on something. Sure, we should be able to. How about a one-dimensional MDSPAN? Yeah, it should work. And again, remember, we're only 3 years into this, right? Forward this to LWG for Library Fundamentals V3, unanimous consent. Again, we're very optimistic. Yes. Fundamentals V3. It never got MDSPAN, right? The first draft was 2018. We are shipping it this year. In 2022, we said, hey, you should publish it. And we took like these polls, like, let's publish it. Let's never publish it. Let's not publish it and take its contents one piece at a time and put it in C++. And the reason is because things go there, I don't want to say to die, but they just kind of live there forever, because it's a place you can just put something and not think about it. There's some like the detection idioms in there. The only thing really added for V3 was scope guard, which I'd like to see, but we couldn't decide some of the finer points of scope guard. I mean, LEWG was bad enough at that the person who authored it said, I'm done, because you guys just keep changing your mind. So we decided this will be the last Library Fundamentals published. And it was supposed to have been published by now, but it hasn't actually come out yet. So hopefully by the end of the year, I mean, there's nothing other than, the editors have to finish it up and get it out there. And since we're all volunteers, that might, take some time. Right. And so my objection to this whole thing was like, there's a sentence in there that says like, the C++ committee intends to release new versions of this. And it's like, we don't. And people going, well, that's just editorial. It's like, we shouldn't lie, right? It's really egregious lies, like, because, the whole reason V3 came out is because we said this in V2. It's like, I don't want to keep saying that. So I kind of pushed, and they removed that sentence. And there's a few other sentences in there that are still little white lies, but I'm okay with them, because like, if we publish it, here's what we're going to do. It's like, it's not going to happen. So back to P009. So, okay, it turns out like there's no actual need to index by span. So we just took it out, because it just adds complexity. If people aren't going to use it, why, we don't want to add complexity just because there might someday be, a use case. We want actual use cases for things. And R5 was not reviewed. And then Daisy Holman came out with a separate proposal just about like a customization mechanism and properties. And yeah, we kind of want like basically span with like 4 template parameters. We don't quite want properties. It was the result of that discussion. So R6, we have a class, we have a basic MDSPAN, and then like a template alias for MDSPAN at this point. And like R7, like, how do we refer to span? Because it turns out span is going to be in 20, not 17, but 20 hadn't been published yet. And, MDSPAN was still going to target a library, library fundamentals. So that's just kind of more like minutiae, like what the committee has to deal with. And then R8 was based on there was an update based on a reference implementation that the Kokkos group did. Hey, 2019. That's when I joined Argonne National Labs, February 11th. A week later, I get to go to Hawaii. Not bad, right? So R9 is wording changes. And there was another proposal that deprecated the use of the comma operator inside subscripting. So, currently, right, you could, do those three things. And now we're just saying like the third one is deprecated. Because again, we know we want to use this for MDSPAN. R10 comes out in Prague. C++20 is done. SPAN is in there. MDSPAN is not in there. At the very end of that meeting on Saturday, right afterwards, I accepted the position of being the Lugie vice chair. And then we had a pandemic. So everything moves to telecoms, right? I'm in the Kokkos group, so now I'm added as an author. And of course, I push for like changing pointer to T to size T. And I want to make sure we're explicit about trivially copyable. Because again, how do we copy objects in C++, right? Normally you have the copy constructor or copy assignment operator, right? But that can involve running code, right? If it's user declared, it involves running code. Or user defined, it involves running code. And that code may access both the source and destination. And we can't necessarily do that if it's between two devices or between like a host, a CPU, and a device, a GPU. I mean, where would that code run? That actually is a very valid question. And if it's running on the device, it may not be able to just read host memory. If it's running on the host, it may not be able to read device memory. So we can copy the bytes, the object representation. And so we've been using trivially copyable as a proxy for types where we can copy the bytes. SYCL kind of uses that. I added another trait so we can overload that. So now we got to put all those, as I said, we split the two papers up. We got to put them all back into the paper. And prefer putting in the IS because no one in the community really likes the library fundamentals TS mechanism because we're just not getting any information back. And still hopeful for the syntax. And so the multidimensional subscript operator showed up because the comma was deprecated in C++20. This is very quickly, we not only made it deprecated, we made it ill-formed. And, this is because we really want to eliminate, workarounds, right? We really want to use, A of, let's just say X, Y, Z. Anyway, we want to use, yeah, we can use the parentheses operator, but it just doesn't look right. And we can say A of, X and Y and Z because you can have proxy types that keep doing things. And so the proposal said, we propose that operator square bracket should be able to accept 0 or more arguments, including periodic arguments, just like the function call operator. And another proposal was a static function call operator that hey, if we're going to do this to square bracket, we should also allow a static one of those. That kind of fell through the cracks. And it's one of the few changes that I got through in the very end of C++23. Those kind of changes normally don't make it. People viewed it more as a bug fix, something we just forgot to do, than something like actually proposing a change at the very last possible moment. And the core working group, well, they like me. So they go, hey, have you ashamed? Because I've never actually had to go to core for anything official. This is the first time I had to go to core and get a language change made. But that's actually part of the nice thing about the committee getting together, not just library, not just language. Like we can talk to each other and we can get things done. And, if we need language changes, we can get them done. So as part of R13, it turns out we don't actually need like the basic one because we can just do MDSPAN, do it all in MDSPAN itself, right? And we also added deduction guides and the square bracket operator. And I'll do my sidebar on deduction guides. Right, so roughly you can say, if you have this thing like pair, and you can say pair T1, T2, and what it does is, so if you just call a pair without any angle brackets, right, it says what class that should actually map to, and then that constructor has to be inside that class. So all parameters must be deduced, right? You can't specify them because you can't put an angle bracket on it. And it creates a different overload set, right? The deduction guide is a different overload set than the constructors of your class. It maps them, but it's a totally different overload set. So like, if I took a pair, int const star t of 2 comma quote 3 unquote, right? That's very, very explicit. And if I use this d, right, it says, oh, I need to map this to a pair of int and const star, and only uses, make sure that there's only one in the overload set of the deduction guide of the CTAD constructors. And, this is an immense gain of usability for types with lots of template parameters. Like MDSPAN, we have 4 template parameters, right? And some of them are complicated, right? The number of dimensions is a complicated template. I mean, the parameter itself isn't complicated, but putting all those in that gets things complicated. But it's still a trade-off, right? If you're declaring member variables like with MDSPAN, you have to still have the exact type. You can't just declare them with without angle brackets. And compile time debugging, you have to know what the real types are. So here's probably my smallest print. Like these are the deduction guides that are in MDSPAN. And so if you have int I, right, int star p equals address of I, and then you do MDSPAN d without no angle brackets on the MDSPAN, here's kind of what happens, right? It looks through, oh, okay, these are the deduction guides. Ah, that one matches. Exactly one matches. That's good. So it matches, and then okay, so I have an MDSPAN int star, and I do the remove reference, right, to make sure it matched, right? And then is pointer int star is a pointer. So then I go through the other transformation to say what are the template parameters for MDSPAN. It says okay, int kind of an extensive size t, and then those have defaulted parameters, so layout right and default accessor int. And then it says there's exactly one constructor in there to call, so it calls that constructor, which is the MDSPAN int star constructor. So that's my 1 minute how deduction guides work. It's a really cool feature. And again, especially for type, I mean, the examples people normally give are things like vector, and it's not all that useful for things like vector. For this, it's incredibly useful. Anyway, back to P009, 14. Should we send it to the library? Yes, we should. This is now we're November, Okay, 2022, we have a wording review, another wording review. And there's a feature in there, sub MDSPAN, and we didn't have time to review it, and I don't have time to talk about it. And about this time, there was a new paper to actually be able to change the type, right? That size type from being size t. But if we just add it as a template parameter, the first template parameter it extends, we can have it just work. And we were being very conservative. We were going to constrain it to unsigned types just because we want to be able to change the size of the type, not just use 64-bit ones, because 32-bit ones are more efficient on a lot of GPUs. And LAWG said, no, don't bother with that constraint. This way you can change the sign if you want to. And so this got put in. And these are all separate papers because we don't want to impact, right? MDSPAN's about to go in, and if there's things still changing in MDSPAN, people go, oh, maybe you should wait because you're making changes to it. So, they don't feel comfortable. And valid stance, but we knew these things were small. And of course, when we were going through this paper, in the middle of that, I think it's either the middle or it was a half hour after that, I realized, oh, we still call it size type. And everywhere else in the standard, size type stands for an unsigned type. So I read a paper to again, I don't want to risk MDSPAN. I gotta go in, but to change it. And that works. I mean, again, if you look, this is people say it's additional complexity. We don't want, it's a late change. We don't want to do it, but that didn't convince people. And we got it in. And we should rename pointer contiguous because contiguous, it's not really pointer, right? Sometimes it's what we like to call fancy pointers, right? It's just a data structure. It's just some kind of smart pointer kind of thing. And contiguous kind of implies left to right linear order, which isn't necessarily true. So we're changing it to exhaustive. And again, separate paper because we don't want to risk MDSPAN at this point. And someone said, hey, you forgot to put empty in there. Well, let's do another paper to empty. It almost didn't make it in because there was a wording bug in it. I mean, it's a one-liner, right? And those are the things that usually end up with wording bugs, because like us humans don't look at them as carefully as we should. So on July 25th, 2022 at 11:25 a.m. Chicago time, right? Apply the changes in P0009R18 MDSPAN to the C++ working paper. Unanimous consent. Yay, celebration. There I am. Okay, that was the Prague C++ 20 Prague celebration. Here's our celebration. Real screenshot. But it was nice. I mean, still, a little bit later, I was looking on. If you haven't seen EL.is, the C++ draft, it's the working draft of C++ standard that you can look up things, and it was there. And like Kokkos had the reference implementation out there, and NVIDIA's put it into their reference implementation. So it was making really, it's happening. And so now this is kind of more current and future stuff, right? So I work on SYCL as well, and we're looking to see if we should embrace MDSPAN as part of the stuff we're doing. Like we can use it like to replace accessors, unified shared memory. That just means there's a flat memory address space across GPUs and CPUs, even if you may not be able to access some of the memory, but it's a flat address space. And we want to be able to do, it's a good time to add more than 3 buffers. And like because SYCL came from OpenCL and graphics, there's like images. And so basically an accessor is a non-owning view of a SYCL buffer. And what it allows you to do over MDSPAN is that it builds a DAG, a graph, so that knows how to migrate memory, and to do that implicitly. That's how all the implicit memory movement happens versus USM, shared memory, because that is explicit data management. And kind of like, yeah, we want, we want to be allowed, we can allow rectangular copy, like copy to the central area of this stuff. And we're still kind of talking about this. We have a meeting next month. I were going to talk about it at the next Kronos face-to-face meeting. That was a few months ago, and that meeting got canceled. There's a meeting next month, so it's not 8 days from today. It's about 4 weeks. If you're near Montreal, I'll come visit. But I can't. And then what Kokkos stuff is working on, so we have a bunch of papers, right? The big thing we're working on is linear algebra. I'm not at all going to talk about that. That's a whole another talk. So MDARRAY, I will talk about. MDARRAY is the owning person, right? It's what way back with shared array was going to be, right? It's the owning version of MDSPAN. And initially it was going to have a container policy instead of an accessor policy. And you need some way to create. And we decided we want to do it like as an adapter instead of as a container. I mean, we kind of always wanted this. An adapter basically, maybe there's a standard vector underneath it, or, in-place vector, or small vector underneath it, or something else, right? We don't know or care, right? We just care that this thing will, is managing that space. So that's why, we want an adapter for this thing. And also, another thing we have to do, so in Kokkos, we have our own, we have our own array class, and like standard array. And the reason we need it is because for things like CUDA, we have to decorate functions with underscore underscore host and underscore underscore device, or they won't run on GPUs. So we have parts of the standard library we have to re-implement just to put those decorations on them. So we kind of need custom types as well. And so instead of just container policies, so yeah, just pass the the container type, right? And so the default should be vector. Sure. I mean, we'll almost never use it in HPC, but that's okay. And we pulled it, and it's consistent with MDSPAN, and we added some requirements, and just drop those requirements, put preconditions on the relevant constructors. And we fixed some of the issues with move from state. Maybe it's hard. So like an MDSPAN with like all static extents, right, is not default constructible, right? If you have a vector underneath it, you can't default construct it, right? Because you have to fill in that data somehow. And like, and there's that problem. And there's also like move assignment modifies both the source and destination. So if I have an MD array with all static extents, right, that's got like, so it says, let's say it's MD array of, T comma, extents 1, right? Even with one element, right, there has to be space for that element. That element always is dereferenceable. But what's a move from state of an MD array? Well, it's kind of a valid but unspecified state, right? We kind of in the standard say, a move from state of a standard library object is in a valid but unspecified state. That means any function without a precondition we can call. Any function with a precondition, as long as we've checked that precondition, we can also call it. But if we don't know the underlying, so in general, you don't, know the underlying state of a move from deck, for instance. So then we don't know the move from state of an MD array, and we don't know if it's valid. We don't know if we can get to those elements. And worse, if both source, if move assignment throws, what's the state of both the source and the destination, right? Now, if it's an array, there's no problem, right? Because like the move, we don't break MD arrays invariants. That space is still always there. But vector, that's not true, right? Calling clear doesn't maintain the invariant. You still have to reallocate its size, and that can fail, right? That can throw. And then user-defined containers, who the heck knows what you can do with that, right? Now, to be fair, other containers with invariants, such as priority queue, don't answer these questions either. And I tried to get the committee to answer me on like flat map and flat multi-map, and they said, no, it's just fine, even though, in my personal opinion, it's not. So we're working our way through. Okay, I said I wasn't going to talk about sub-MD-SPAN. I'll just show it to you at least, though. Right, it returns a different MD-SPAN type. It's basically lets you kind of like slice some, middle parts. Like if you wanted that little square rectangle, we'll let you do that kind of thing. And it's got an index type, right, tuple, and and no time is running out. So, you can do a strat index range, the start index length. And then there's some customization things. You can customize the offset and the mapping. And in Varna, we approved it. So this is going into C++ 26. And there were some kind of like MD-SPAN layouts. Want to allow a padded one. That one, there's no open technical issues, but we've not actually voted on if we want it into the standard yet. So, and here's something else I'm working on: atomic refs bound to memory ordering atomic exiters. Like I said, if you have an atomic ref in there, and as how you do references, you can do it. So as part of this, SG1, which is the concurrency and parallelism subgroup of the committee, they want like atomic ref relax, spelled out, a type spelled out that way that doesn't let you say. So the way normally with atomic ref, if you have different memory orderings in it, you pass those in at runtime as parameters to whatever operation you want to do. And SG1 wants one that says, no, we don't want those runtime. People make mistakes with those. We just want to say at compile time, this is what it is. And so LEWG and Issaquah this year said no. So when I wrote this up, I wrote it up atomic ref bounded as a exposition only type because I didn't want to expose the template because it's not very general. Like if you look at atomic ref acquire release, right? The loads have to be done with acquire and the stores with release versus both relax and sequentially consistent. It's just done with memory order relax or memory order sequentially consistent. So I didn't want to expose it. LEWG wants it exposed because I specified it that way, and no good deed goes unpunished. And so on top of that, all we do is change what the reference type is inside like atomic accessor to use atomic ref or atomic accessor relax, just change it to use atomic ref relax, and everything just works. I've given this talk before, and one person asked me like, will this work with vector bool? And I feel bad because I said no, and having thought about it longer, it would actually work with vector bool if you just change the reference type to what vector bool returns. So yeah, this really stuff just works. It's really just plug things in, and it, compiler just makes it work. This is just a bug fix. The layout stride default constructor was default constructed. Now it initializes its internal extents and strides. That's going back into C++23, kind of as a bug fix. This is another bug fix. Basically, you could accidentally overflow the index type because now you can specify the index type, right? You can make it like, unsigned char, right? So we just say, okay, well, we're just saying, nope, don't do that. And this is a new one coming. Basically decorated pointers with, there's a C++20 feature, assumed aligned, which informs the compiler that the object pointer points to an alignment that's at least n. And that is going to be discussed probably in 20 days. I can't promise that. We may have to reschedule it, but that's something new. And again, this stuff will just work. It's very, these are very simple classes, and plug and play just works. So in conclusion, yeah, no one thought they'd get through 180 slides, right? Right? It took 8 years, to be designed, refined, and standardized. But it was based on many more years of practical experience. And we got buy-in from a lot of different, people and organizations. And again, people say the committee, we do design by committee. We don't. We do consensus by committee. Designs are done by people willing to write the papers and, shepherd them through. And in my opinion, right, the result of this is a really good library. And it is, and a lot of people have said this is one of the flagship libraries of C++23. Thanks to Argonne, Kokkos, the committees, thank them, blame me for this. Sponsored by the Department of Energy, and that is my talk. Any questions?
So folks, we do have, the mic is open to just the room in general, so if you got something, just speak up.
Yeah, you had a lot of comments that basically implied that your users, Argonne or whoever you're affiliated with, are using a lot of explicit memory control, explicit copies and so on. Do you see this continuing as a requirement for a long time, or do you think that things like Grace Hopper and the memory management stuff that's coming along and has been there for game consoles forever, that model is actually going to predominate in the long term with perhaps hinting or prefetching or something like that to assist on performance?
I think both models. I think we're still trying to get the implicit model, still trying to get good performance. Is still not quite a solved problem. I mean, it works in many domains, but it's not perfect. And I think the flat memory model is a lot easier for people to program, although the implicit one makes for a lot, much shorter programs, right?
Yes, I was wondering in particular with regards to MDSPAN, if you, for example, in another life, assumed that you had flat memory, available, and assumed that you had explicit and so on, would things have changed significantly, or is basically that's just an option and it's hidden and you don't worry about it?
I think it's just an option as long as we have a parameter that lets us figure out a way to access memory, right? It kind of like assumes that you somehow have some kind of flat way, and you can map that yourself, right? You can provide the accessor policy, right, to say how you want to map that to something real physical hardware. I think as long as we have that, it keeps us open for the future, because we really don't know, right? I mean, as we just internally discuss, like where's HPC going, right? It's like we don't know, right? We don't know where we know there will be great developments. Maybe they'll be in storage. Who knows? We don't actually know. We don't want to bet on just one of those things.
Second question is, do the backends gain any benefit at all from basically any information passing through from MDSPAN? Are they semantically aware of it? Is there any kind of backend hookup with this where they can generate better code? Or is
well, in Kokkos view, yes. I mean, like we implicitly take layout, right? So if we know we're going to be on, we layout left is column major is better than row major, right? It'll certainly just benefit by default out of that. So yes.
I'm sorry.
That's why, right? Because users won't have to specify that.
And sorry, I had a third question. Does anybody at Argonne use halide, or is that not really a thing in your world?
I'm sure people do. I don't, but I'm sure people do.
Okay.
I've heard of it, so don't really know much about it. So not in my little corner of Argonne, right? I can't speak for like all what.
Thanks for the presentation. Enjoyed it.
Sure. Yeah, I've known maybe I have to look at how many people we have. That's the downside of working from home, right? Is I don't interact that much.
We never have these problems in EWG. We just send things over to Core and have them spell check it for us.
Yeah, Core pushes back a lot. It's actually so does LWG now, and they should, right? I mean,
yeah. Well, if it passes Core, we know it's good enough.
Okay,
it's more, the question is how do we get more, more core experts and more, library wordsmiths, right? That's one of the things the committee's not solved.
Hey, you got rid of Bryce, so.
Now, come on.
So I'd like to ask a little bit, so MDSPAN, what do you see it primarily being used for? So it seems like it's really going to be really good for processing high dimensional arrays, but what kind of applications want to do that? Obviously, a graphic card will want this, but what do you think they'll be using it for?
I mean, in Argonne, we're using it, because we do physics simulations and certainly use it a lot for that kind of thing. But that's a lot of what HPC does is simulations. And we found basically up to 8 dimensions covers most of the cases. And so on SYCL, we're actually just trying to decide, should we limit ourselves to 8 dimensions? Should we allow n dimensions, right? Because in C++, it's easy to allow n dimensions, right? It's a variadic. But we're not going to, no one's going to optimize, much past like even 8's a lot to optimize, right? And we're trying to figure out the trade-off between how much of, how much do we need to optimize to solve real problems versus, just let people express their problems. Right, because we don't want people to have to hand optimize things. Like right now in SYCL, if you have more than 3 dimensions, you're hand optimizing because you don't have a choice, right? We'd like to remove that limitation and provide good performance.
Has the question, got his hand up.
Okay. Can you hear me okay?
I hope that answered the question.
Go
the other
for it.
downside to remote things. I can't see like audience reactions. So
Yeah, hey Dwayne, go ahead
Oh.
and just talk. We should be able to hear you.
Oh, okay, you can hear me?
yes.
Yep, I can hear you.
Cool. I was just going to comment on the multidimensional upper limit because I've recently been looking into this for the sake of the WebNN standard. And so I looked across like XNN Pack, DirectML, NVIDIA, cuDNN. And yeah, most of them are 8D is a pretty good upper limit.
That's good to know. Yeah, no, it's more than just us thinking that. Yeah, it's hard. It's a hard question, right? Because it's in C++, there's no general reason to limit it. And in SYCL, I think we're kind of like what we're kind of looking at it is we'll implementers will be up to them to decide how much they want to optimize, and you can query that. But you can express things bigger than 8 dimensions, is what we're looking at for SYCL. Kokkos has no plans anytime soon to lift the 8-dimensional limit. And a lot of Kokkos, started around C++11, and variadic support wasn't, it was just coming there, right, at that time.
Thanks.
Okay, anyone else? I guess we'll call it a wrap. Thank you very much, Nevin.
Thanks,
I'm
David.
glad to do it.
Yep.
Maybe someday I'll get to visit. I keep missing trips to Washington, so one of these days I'll get out there again.
Yeah, if you're in the area, let me know and we'll schedule a meeting. How's that?
Sounds good.
Okay.
It's seen in about 10 days.
Don't remind me. I still have my other talk to finish.
Well, let's chat for a minute. We got the video turned off.
But Michael Wong always invites you along. And invite.
Yes, he does.
I'm surprised Michael didn't have his name on any of those papers. We got Gordon.
Oh, he'd rather be moderator, right? And just make the rest of us do things.
Is, you want to reschedule the meeting?
Hang on 1 second. Let's see. So stop recording.